Hello everyone and welcome you to the grade 7 ICT unit number 1 Central Processing Unit. So this is the most important part in our computer system. So if you talk about the human, what is the most important part? It is our brain. Likewise, if you talk about the computer system, the most important part is the central processing unit in our computer system. So if you talk about the computer system, there are a lot of parts are there. But out of those, the central processing unit is considered as the main part of the system. So where this central processing unit, or we call shortly the CPU. The CPU stands for Central Processing Unit, right? So when you talk about that one, so if you consider that one is like, so computer is like a kitchen in a hotel, and the central processing is like the chef in the kitchen because he is the boss. If you take the kitchen, right? As the chef prepares the food, the central processing unit processes data in the computer and converts them into information. We know if you talk about the computer, it's an electronic device. Okay, so it takes the data and it converts them into the information, right? So as the food preparation speed depends on the speed of the chef, the speed of the computer also depends on the central processing unit. So you already know if you have a faster computer, you can do the calculation and the works and your homework and the other things faster. So likewise, there are different processors in the world. So we will see what are those later. Right? So when you take, there are different cores are there. That's called single core processors are there. There are dual core processors are there. There are quad core processors are there, and there are now octa core processors also there. So according to that, the speed also depends. Speed also increasing. It means if you are doing in a single processor a work, but if you're doing that in a dual core processor, you can do faster than a single core processor, right? So let's identify where this processor is. Where's this one? Where's the central processing unit is located? So this central processing unit is in our system unit. You know, in a computer there are a lot of parts. There's a monitor there, there's a keyboard, mouse, but you can see all these devices connect into a one particular device. That is what? That is the system unit. In the system unit, we can find out this central processing unit. So if you open the central processing unit, you can see there's a motherboard. In this motherboard, you can see the processor. So we will see a small video about this processor now. Okay, everyone, let's see the video about our processor.
In this journey with the Central Processing Unit, or CPU.
Okay, you can see this is the motherboard. This motherboard will have the processor. So you can see the processor is situated in the motherboard in your computer.
Which is the brain of the computer. On top, we have the cover, called an integrated heat spreader, and inside is a smaller metal package that holds the integrated circuit, which is technically called a die. This die is mounted on a printed circuit board that distributes the 1200 connection points to landing pads that interface with the landing grid array on the motherboard. The integrated circuit inside has a few different sections, but perhaps the most recognizable are the 10 cores where programs and instructions are run. Each core is quite complicated, so here's a diagram laying out the different functional sections. There are dozens of rather complicated elements in this diagram, and you can look forward to a series of videos we're currently planning which will explore computer architecture and how each of these sections work. Let's zoom into a nanoscopic view of the integrated circuit so we can see individual transistors. These transistors are incredibly small, only a few nanometers wide, and in this die there are approximately 8 to 10 billion. On top of the transistors are multiple layers of metal wires, with vias rising vertically between the layers. Together, these transistors and wires create a multi-layer labyrinth or highway, resulting in a computer that can execute billions of operations every second. Let's now zoom out and look at other sections of the CPU. To the side of each core is the shared L3 memory cache and ring interconnect. On the far right is an integrated graphics processor which functions as a less powerful GPU. In the top left is the memory controller which sends data to and from the DRAM. And finally, on the far left is the system agent and platform I/O, which communicates with the chipset on the motherboard and manages the flow of data between many of the other components in your PC. So with that in mind, let's move on and look at the motherboard. This motherboard is a massive printed circuit board with thousands of wires running inside and a variety of microchips, components, sockets, ports, slots, headers, and connectors soldered to it. Perhaps the single most important and expensive component, aside from the bare PCB, is the chipset, which is this integrated circuit found underneath a heatsink down here, and is connected directly to the system agent section in the CPU. Here's a diagram illustrating how the CPU and chipset are connected to everything else. As seen here, the CPU connects directly to the DRAM, one or two displays, the GPU, and perhaps a few SSDs plugged into the M2 slots. The chipset manages most everything else: data flowing through the Ethernet or Wi-Fi, data going to and from solid-state drives and hard drives plugged into the SATA ports, some of the PCIe slots, your keyboard and mouse, USB devices, and the audio sent to the speakers or from the microphone. Just a quick note. Computer hardware has evolved immensely over the past 65 years and continues to evolve. So the details we show should be thought of as a current-day example PC and not as how all computers work. Let's move on and skip over the many different sockets and connectors throughout the motherboard and focus on the voltage regulator module, or VRM, found near the CPU. These components are used to drop the voltage coming from the power supply down to the 1.3 volts used by the CPU. As a result of all the power flowing through these components and their 80 to 90% efficiency, heat sinks need to be placed on top. While we're on the topic of power, this CPU consumes power equivalent to approximately 16 LED bulbs, thus generating a considerable amount of heat, which is taken away by the CPU cooler. This particular cooler uses a pump to circulate liquid through these tubes and into the radiator's channels, which transfers heat to the radiator fins. The fans then help transfer the heat to the air, and the cooled liquid returns to the pump via the return loop. The pump is a brushless DC motor, constructed from a PCB, a control chip, and a stator on the dry side, a barrier in the middle, and then the permanent magnet rotor and impeller on the liquid side. There's no mechanical connection between the rotor and stator, thereby preventing any leaks of the cooling liquid. Let's move on to the power supply.
Okay, so you have seen now how the CPU works and where the CPU is located. right? So we have seen now where the CPU is located, right? So we have seen that one. Now we were going to identify, if we take a CPU, there are three major components. There are three major components. First one is the ALU, second one CU, and the third one we call the memory registers, or we call registers. So if you talk about the ALU, so ALU stands for arithmetic and logical unit. And the CU stands for control unit. And there's a memory registers in our system. If you talk about the ALU, so you know when you are sending a question, when you're sending a calculation, that calculation part will take by our ALU, or our arithmetic and logical unit. So in this unit, it performs all the calculations in the system. So the mathematical and the logical functions are performed in the computer. It's done in the ALU. If you talk about the mathematical function, there are mathematical and logical functions. So if you talk about a simple calculation, we have to add, we have to subtract, we have to divide, we have to multiply. Those mathematical functions also done by in here. And there is a logical functions also be done. So you need to compare, right? You want to see which number is larger, which number is smaller, which number is equal. So those kind of things also doing under the ALU. The ALU is specially used for mathematical function, or the arithmetic and logical function in our system. So it performs mainly the calculation part. Okay, right. When you go to the next part, it's the control unit. It's like, so who's the boss in your house or your school? Likewise, when you take your home, your main person is what? Main person is your father or maybe your mother. If you take a school, it's the principal. So here we have the control unit. He is the person, he is the unit which control all the hardware components which connect to this device. So it gives all the instructions to perform. So he will say, okay, get ready. Now there's a printout coming. So when you give a printout, example, you say you have created a Word document. You create a letter. Now you are going to take a printout. Now from the Word, you are going to file and you are going to say print. When you press the print button, then that signal will go to the printer through the control unit. This control unit will say, okay, printer, get ready. There is a printout coming from Word, ready to take it. So that kind of a thing is controlled by the control unit. So it's the main component, main control unit in our CPU unit. Okay, so it is the all the controlling unit under the list. And if you talk about the next one, is the memory registers. So it's a register, it's a kind of a temporary store instructions there to give the support for the CPU. It's a temporary store data and instruction that are being used by the CPU. The storage capacity of the memory registers is very low when compared to other memory devices. But if you talk about their speed, they are the fastest. The memory registers are faster to perform the calculation and to give the instruction. Right? So we have learned, if you talk about the CPU, CPU consists of major three components. There are ALU, CU, and memory registers. Right? And the CPU is located in the system unit. And the system unit, we have a motherboard. Right? So we have now come up to the here. What are the we have know now? What are the major components of the CPU and what are their duties? Right, everyone? So thank you, everyone. We will see you next time with the computer generations. The computer generations in your unit number 1. So we already discussed what are the components of the CPU previously. So now we are going to see what are the things happen to the CPU from the beginning. Now there are different CPUs in the market, but we are going to see how the current processors or the current CPU come to this moment. So if you talk about the computer's CPU, there are 4 generations talking in your book. But remember, there is another generation we need to talk about. If you talk about the generation, there are 5 generations actually. But in your book, we have to see only 4 generations. First generation, second generation, third generation, and the fourth generation there. There's another one we have to see is the 5th generation one. If you talk about here, right? So here in this one, so we have the first generation. In the first generation, the major technology we have used is we call the vacuum tubes. So you can see a picture of this. And if you talk about the vacuum tubes, they are very huge. They are very huge and we need a lot of electricity for that. And we need a large space. And we need a large cooling system also. Why? Because of the heat. So we have to cool down the system by using a large AC units. So it's a very expensive computer in the first time. So if you talk about those, so they were used especially in the scientific purposes, as well as it was the speed. If you consider speed, they have measured in milliseconds. Milliseconds they have used, and you need to spend a lot of money for that. And for some examples, if you take it to the first generation, we can take it ENIAC, UNIVAC, and HVAC. And there's a one called HSAC also. We will see at the end of this part a small video about all of these. All right. Okay, let's see. Go for the second one. So second take one, when you go to second generation, we are having the transistors. Now the scientists were thinking about now these computers are very large. How can we make it smaller? So now they have replaced the vacuum tubes with these transistors. So transistors replacement make the smaller computer than the first generation. So it reduced the power and it reduced the size. But in this time also, they measure the speed by in microseconds. They have used the microsecond for that. And for example, we have can see is the IBM 7030, CDC 1604 are some of the examples for second generation. Then if you go to the third one, they have replaced the transistors now with the integrated circuit, or shortly we call it ICs. Okay, I think you may have seen ICs in some circuit boards, these kind of ICs. So integrated circuit, it's mean in the one integrated circuit, it contains thousands of transistors. So you can do the thousands of transistors work by one IC. So due to that, what happened? In the third generation, computers become even smaller. So smaller than the second, and the execution speed is we have measured by the nanoseconds. And the example for these computers are in this generation is IBM 360, CDC 6600 are some of the examples. And if you come to the fourth generation, we have microprocessors. So microprocessors are make them even smaller. Right? So smaller computers were introduced and the microprocessor, your microchips were introduced in this period. And they have measured speed in millions of instructions per second and picoseconds. Then if you can see, they have mentioning as here in your book as they are the modern computers there. Okay, let's see a small video regarding the computer generations. I think you will get a clear idea about the generation after this. Let's watch a small video about computer generations. So thank you everyone for joining, and we will see you next time with your unit number 2.